Hey, hi everyone. Welcome to my channel, The Next Gen AI with Sai. So today we are going to see one of the very important topic in LLM and specifically in the RAG. It's called as the retrieval mechanism. So today it's bit a kind of combination of theoretical plus practical, but it's more kind of theoretical based. Definitely, I have some code to showcase you, but it's very much important you to understand the mechanism behind the retrieval. Okay, there are many things in the rack, in the advanced rack has been developed till now, but today we are going to only focus on the retrieval part. Okay, so let's not wait and jump to the topic. Yeah, so uh, you know that how the any rack system works. Okay, if someone new to this, so let me explain it again. Generally, you send a query to LLM, then there are some retrieval. This retrieval will retrieve the data from your documents based on the user query. Then that data plus the prompt is sent to the LLM, and then you will get the output. I hope everyone knows about this standard rack system. Now, what is the mechanism? So today we are going to focus on this retriever mechanism, right? So how this retriever mechanism works so that the data will be fetched based on the query, right? So there are three different mechanism is available. One is the keyword search, second is the semantic search, and the third is the hybrid search. Definitely we are going in depth and understand what different algorithms are used behind each search. Okay, and we will try to understand, but just as a definition level, the keyword search is something that based on the user query it will do the exact match of the keyword words with the document that have, and it fetch that data. Semantic is something is related to the semantic meaning of your query and the data, and the hybrid search is a combination of both. Okay, so let's first understand the keyword search. Now the keyword search, one of the very popular algorithm is available in the keyword search called as the BM25. So what is the long form of B125? Let me just B125 is the base match 25. Okay, and this base match 25 is based on the algorithm called as the TF-IDF. Okay, so this is the algorithm we use. On this algorithm, this BM25 works. So before we understand the how base match 25 works, let's understand how the TF-IDF algorithm works. You know that the TF-IDF is one of the very initial stage of algorithm that is called as a term frequency and the inverse document frequency, right? When I say term frequency, so term frequency is nothing but the as word status that we're trying to find out the how many times that number is occur in the document, right? So we are trying to calculate the frequency of that word appear in the document. The second term, so in short, I can say that the term which is more significant in the context of document has the higher value. The second term in the term frequency called as the IDF. So IDF is stand for the inverse document frequency. So what is the inverse document? It will tell how unique and the rare word across the entire. So we wanted to find out the exactly opposite to the TF frequency. So we're trying to find out the unique words. Okay, let's say if some terms appears in a mini document, then the IDF score will be the low. Okay, and it's a less discriminative. So TF calculating the frequently occurring words in the document, and IDF will trying to find out the unique words in the document. So this is the basic I can say the basic mechanism behind the TF idea, and then we will try to multiply. We You already have come across, but if you feel to make a detailed video on the TF idea, just let me know. But I have given you the initial understanding of the TF idea. Now, uh, but there are some disadvantage in this TF idea. Okay, and what are those disadvantages that will come to know? But let's understand. LangChain uses the keyword search mechanism using one algorithm called as a BM25 OKPy. Okay, this is one kind of, you can say, one of the progressive version of the BM25. Okay, so base match 25 is also have the something similar, but it's a library the LangChain uses called as BM25 OKPy. Okay, and based from that they uses this thing. Now how this works, it is also a same baseline is the same. If you look at the, if you look at this first terminology, that is a log n divided by dfit. So what is this? This is nothing but the your idf. Okay, idf. What idf stands for? Idf stands for the inverse document frequency. Okay, so again, the purpose of this inverse document frequency is to find out the unique value. Okay, if some value is occurring majorly, the log value of that becomes 0. For example, if let's say that the word is appearing frequently in the document, okay, so it the frequency will be the 0 because the log of 1 is become 0. So that is the mathematics behind that, but just for your understanding, uh, I have pasted this thing. The second part is called as the TF-IDF. Okay, so we have this term called as a TF-TD. So what this call, this will calculate this two term TF-TD. This will calculate the term frequency. So the backbone of this BM25 is the TF-IDF. But there are some limitations of the TF-IDF. Because of that, they have added few extra parameter, something called as a K and something called as a B. Okay, we will understand in a minute what is K and what is B. Okay, so N, what is N? N is the number of document. Then we have the DFT, which is nothing but the number of document which containing the term T. Okay, so DFT is called as the document frequency. Then TFTD is the number of occurrence of that particular term T in the document. So it is called as a term frequency. I already written here. Now there is a one term called as a LD. LD is nothing but the length of the document. What it is called? Length of document. Okay, and the L average, this term is called as the average document length. Okay, we know that there are multiple documents, so L is the length of the document and the L average is the average length of the document. Now there are two parameters. I'll talk in a minute about this, B and K1. It's a tunable parameter. Because of that, there are some disadvantage in the TF-IDF document. It's overcome by this two parameter called as a B and second is the K1. Okay, I hope you understand this part. Let's move to the another. Okay. Now let's understand what is the limitations of the TF-IDF. Okay, the first limitation of the TF-IDF is a non-linear term saturation. Okay, so what it means that if you increases the 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 term frequency value, that is the TF value, it increases the linearly with the count of term in the document. Okay, so if the term is appearing more in the document, your TF value becomes more. So it disproportionately boosts the document relevance score, even the additional occurrence providing the diminishing information value. Let's say for example, the word call as a the, right? It appearing more frequently. But does the or any other words specifically, if doesn't have much more value, there is no use, right? So if some words appearing more frequently and if doesn't carries the importance or informational value, then the TF idea not work well. Okay, and to overcome that, the best match 25 algorithm can come with the one parameter called as a K. Okay, that K is called as the term saturation. Okay, so it diminishes the frequently occurring term and it ranges between 1.2 to 2.0. Okay, so this is the value they generally use to control the frequently occurring term. So this is the first limitation and this is the limitation overcome by the parameter K, which I have shown you in the formula. The second is the document length normalization. Okay, now you know that The longer the document, it may unfairly favor based on the long term count, right? So if the document is more, it may say that the value is very high. Okay, and it is very much important to normalize that thing, because you know that the sum of the document is small, some of the document is very high. So it may be the possibility that your term frequency value, okay, which occur in the lengthy document, is influences the term which are appearing in the small document. So it is very much important to have this kind of normalization, and because of that, the term which is added called as a B in the BM25 algorithm called as a B. So and that B is something is called as it normalizes it normalizes the term frequency based on the document length. So these are the two major disadvantages in the TF-IDF document. Second, it handling the third disadvantage is handling the rare and the common words. Okay, so this is the third disadvantage of the TF-IDF. Now let's talk the detailed comparison again here. Okay, so this is the sum table I am giving you so that you can understand. No need to mug up, but let's try to understand each and every parameter. The first aspect is the term frequency. You know that the TF idea is linearly increases once the frequency of the term increases. So it sometimes it overestimate the importance of frequent term. It may or may not be important in the document. However, that is been overcome in the BM25 using the parameter called as K. So this is the non-linear saturation and it reduces the excessive influence of the frequent term. Second is the document length. Okay, so in the document length there is a no adjustment. It can favor or it can penalize the long document. Okay, so there is a no adjustment available in the TF-IDF. However, in the BM25 OKPI there is something called as a parameter P. It explicit the normalization and it balances out the long and short document. So generally, you know that there is a process of normalization is very popular in the machine learning. Same mechanism happen here. It normalizes and it doesn't give the importance to the specific word based on the frequency that word occurs. The third aspect is called as a parameter tuning. Now in the TF idea, there is no parameter tuning you can do. It's a simple formula. It's a mathematics behind that. Okay, you just multiply and you get the score of TF idea. But in the BM25, you have some adjustable parameter that is called as a K1 and the B. K is for the saturation purpose, so you can reduce the importance of some influence term, and the B is for the length of the document. Third, definitely TF-IDF is very simple, but it is less accurate for the complex and the retrieval task. So in real scenario, for the small task, definitely TF-IDF works better. But if you go for any practical or any industrial based application, TF-IDF fail. So in that case, this BM25 it helps a lot. Okay, okay, it helps a lot. So in performance wise, the BM25 definitely accurate. Okay, it widely used in almost all the modern search engine and the retrieval system. The fourth aspect is handling the rare and the rare handling the rare terms. Okay, now the rare terms which gets high score. Okay, generally we know that the IDF will penalize the frequently occurring term. So rare term generally get high score and common terms almost get the no weight. This is again one of the disadvantage in the TF idea. But in the BF25, now how why this happen? Let me come to this point. Why this happen? It's happened because of the IDF. We just saw some time back. But in the BF25, that was the not issue. It balances out between the rare and common terms for the better and the practical relevance. Right? Now I hope you understand what is the difference between the TF-IDF and the BM25, right? Okay. Now let's, before we go jump to the semantic similarity, how based on the semantic the document is getting fetched. Let's understand the code, how this things works. Okay. Now, yeah, it's already there. So we are going to install the bm25 rank library. So I have already installed this library, so you can see, right? Now after the installation, we will import the library called bm25 occupy, and this is the corpus. My corpus contain few words. Okay, so let me zoom in bit so that you guys able this. Okay, fine. Okay, now the rank 25, this corpus has something, so something called as the four. I curated the four sentence. The first is the cat commonly refer as the domestic cat or house, and the small domesticated carnivorous mammal. Then we have the second term called as the dog is a domestic descent of the wolf, and then humans are the most common and widespread species of uh, primate, and the last surviving species of the genus Homo. And the fourth word is something that the scientific name of Felis catus was proposed by the Carl Linnaeus in 1758. So something it is related to the some, then like first and the last is something related to the cat and the humans. So it's a general few statement we have. Now this is my corpus. It is made up of four. So it is a list and it contains the four sentences. And this each sentence we will treat as a one document. Now first before that I need to split to do the some tokenization. So I have used the split method with the space and I have created the list. Then I send this tokenized corpus to the this library, okay, and it will generate the core. Okay, now here we use the query called as the b, what is the scientific name of the cats. Now when I pass, now I have this query. So the the way we treated the document, it is very much important. We also need to tokenize our sentence with the split. So we split our query with the space, and then we wanted to calculate the scores. Okay, calculate the scores between the query and between the corpus I have, and likewise will uh, and so we use this bm25 get score. We will use this query and the document, and we want to calculate the scores, how the each uh, document inside this list is related to my query, right? The for query we have what is the scientific names of the cats, right? So if you look at this, let me use this. The first sentence is something related to the cat, correct? The second is something related to the dog. Third is something related to the human, and the last one is something which is related to the cat, right? So we assume that the score of this should be comes maximum, because out of these many words, the scientific come here, the name come here, right? And the what is something. So these two words exactly match with the fourth sentence as compared to first three sentence, right? So definitely the score must become high for the last word. Okay, so it's a keyword match. Okay, it is not semantically match, it's an exact keyword match with the document. Okay, so this way the keyword match works here. With this, and let's try to execute and let's see what is the score. Now you can see the score for the first word is a 15, second is the 20. So I think second is higher score than the first, because if you look at is comes, then the is not scientific, not name, not for, not cat. No, cats, it's a cats, it's a cat. Okay, so cat comes. Then the third one is the again having the more value than, but the last one has the higher value. Okay, now yeah, let's try to find out the keyword match with the something different name. By the way, feline is the cat. It's a word from the cat family. Okay, and we'll try to see whether it matches or not. Okay, so when we run this, every document comes score as a 0, because as I mentioned, it's not semantical fetching of the document, it is about the keyword match. Okay, so this word is not appearing in anywhere in the corpus, so definitely score comes or 0. Now I hope you understood that how this keyword match works, and for the keyword match we use something very popular library, popular algorithm called as a BM25, that is base match 25, and how it is popular than the TF-IDF I already explained. If you have any query, please feel free to comment in the section of this video, comment section of this video. Now let's jump to the another uh, algorithm to fetch the content is called as a semantic match. Okay, so for that we know that how the semantic search use. Okay, so generally we what happen, we convert the each word into the vectors. Okay, and then we will paste into the vector space. Okay, so I will explain in detail. So let's say this is a dimension d1, this is a dimension d2 space, so this whole thing is called as a vector space. Okay, vector space. Definitely in vector space all the words are converted to the vector. What is vector? Vector is a stack of an array which has some numbers. Okay, and each number has some meaning. Okay, and it is why it is called as a dense. The dense because when we use the and when we convert into the vector, okay, it is not just a single number, it has a multiple number. Okay, so every word has a it's a combination, or it is a stack of multiple numbers. Okay, and that's why it is called as a dense. Opposite to the dense, there is another matrix called as a sparse matrix. Why it is sparse? Because some of the number, let's say cat, okay, just for an example, for just understanding I'm explaining, there are maybe some numbers are considered as a 0 and some of the as having some numbers. So this kind of matrix is called sparse if the vector has a some 0. Okay, now if you see the cat and the feline is much more closer as compared to human, and it's definitely practical. Now we have one second statement which is something related to the dog. Okay, if I have a dog, so semantically dog and cat may not closer, but this thing comes to the animal family, so it should be close to the cat word as compared to the human. Okay, so the words which are very close, the angle between them, which is called as a cosine angle, are very close to each other. Okay, and the words which are not similar, they are far from each other. Okay, so this way we will place all the document in the vector space, and we will try to find out the vectors of those words which are close to each other, so it means that they are semantically similar. Okay, I hope you understood this part. Let me now delete this and go to the next. Now how this process of conversion of your text into the embedding. Now what is embedding? Embedding is nothing but the conversion of text into the vector. Okay, this process is called as the embedding. Okay, now each text is converted into the high dimensional vector. As I already mentioned, the dense vector is nothing but the each entry is a meaningful number and sparks as a 0. Let's say I have the word called as the cat. Okay, first before embedding I need to convert into the token, so I will convert into the, then I have something called as a space colon C A and T, right? So I convert into the token, and now definitely the machine understand the numbers, not the word, so we will map each token with specific number. Okay, now there are many algorithms are available which will help to convert the word into the token. Okay, so tick token is one of the popular library which will convert your word into the tokens. Okay, so we associated each word with the number. This process is called as the tokenization. Okay, maybe I'll create another video how the tokenization, and again there are few algorithms which very much popular for the tokenization, so we will have the another video for this. Okay. And then we have LLM, that is called as the not LLM, sorry, This is something called as the encoder. Okay, okay. So we have something called as the encoder. Okay. Now this encoder, what will does, it will convert the each. Now this the is converted into the vector. Now if you look at, it's have some number. It's not only one number. It's have number, and each number has some different meaningful this. Okay. So generally this vector covers the different aspects of the word. Okay, because it assumes that the each word is come from which specific aspect. So we will not go in depth, but that is the something. Then this space is related to this vector, the C is having this vector, A is having this vector, and etc etc. Okay, so this way we convert the text into the embedding, right? So let's move, delete this. Okay, now this is, we have something called as a scatter plot. Now if you look at this scatter plot, we have so we have placed all this thing into the, we have space into scatter plot. So I have this my text 1, text 2, text 3, text 4, and text 5. So whenever we ask any question, this question will place in the dimension and try to find out which text is very close to my query. Okay, semantically. So this is not the keyword based, this is the semantically. So those words which are semantically similar to my query, those texts will fetch. Okay, and it passed to the LLM. So this is the representations of your sentence embedding. Okay, okay. Now to find out the sentence similarity, we use the cosine similarity, and this is the formula to calculate the cosine similarity. Okay, so what is the formula? We are taking, let's say there are two vectors, A and B. So we will take the dot product of A and B and the multiplication of the document. So we divide the dot product of vector by magnitude of the vector. Okay. Now, if my cosine similarity value, so generally cosine similarity value comes between -1 to +1. If my value is +1, it means that those two vectors are very similar. If my values come 0, means these two vectors, okay, are unrelated. So what I'm trying to say that if this is my query and this is my document, now you know that I have document 1, 2, 3, and 4. So we will try to find out my query. So definitely this query is in the vector format. My document is also vector format. Let's say this is vector 1, this is vector 2, this is vector 3, and this is a vector 4. Now my this value of query of vector, I can say this is a query vector. We will try to find out the cosine similarity between the query vector and the first document vector. If value comes related to the 1 plus 1, so I can say this document is relevant for me. If value comes to the 0, means this document is not relevant for me. And if it is come as a -1, so they are exactly opposite, means no relation at all. Okay, exactly opposite. Okay, so if I say man, then there may be a woman. Okay, so exactly opposite, right? So something similar to like that. So this way, this cosine similarity help us to find out which documents is, which vector is similar to my vector. Okay, good. Now let's move to the okay. Now let's check the code. How we can use this cosine these semantic things. Okay. So for the semantic similarity, again we will use sentence transformer. Okay. So let's uh, install quickly. Uh, then for the sentence transformer, we will use this class sentence transformer, and we will use the one of the famous model called as all mini language model L6v2. It's available, and this, with the help of this model, we will create the vector of 384 dimensions dense embedding. Okay, so I already have, but let's run it quickly. So we already have this. Again, we have this corpus. We will use our model and send our corpus to this model. It will do the encoding part. And if you see that, as I mentioned, this model has a 384 dimension. So when I say 384 dimension means what? Now let's say, so I have document 1, 2, 3 and 4, and so it has dimension something like that. Okay, so it start from 1, 2, 3, uh, 4, 5 and 6. So dot 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 dot, so it almost have this 384 dimension. Now you can understand that what the big vector size we have. Okay, similarly if you go to the more and more advanced model, the dimension is goes on increasing. As dimension increasing, so we are covering many properties of the specific word, and your context will be getting, your semantic understanding will also be higher. Okay, so nowadays this big language model has this capacity of creating large vector. Okay, so 384, and then when we execute this, now you can understand I have shape 4 into 384. 4 means rows, 4 rows, and my each rows has a 384 columns. Okay, or you can say vector size. Now I have used the same query here as well, that what is the scientific name of cats, and again I need to convert that query into the embedding format. So I use the same model, and now we will use the cosine similarity library from the sentence transformer to check how these two words are close to each other. Now when I execute, you can see that my first word is something similar to the cat, so therefore it comes at the value 0.5. Second is not that much of similar. I already explained that it's related to the dog but is close to the cat, so comes better value. However, the third value is related to the human, so it's much more far than the word cat. Okay, so semantically is unrelated, so it's close to 0. And the last word is something which is close to the meaning of you what question you ask. Okay, so that's why it's coming as a 0.57. Similarly, my keyword search, I use one word that is called as a feline, which is something from the cat family, and my keyword search was feline. Let's see how the cosine similarity works. So when I use this cosine similarity for feline word, and the score this time is better, it's not 0. Okay, so first one is having much closer as compared to the rest of, and the third one is exactly 0 because it's unrelated to the word for feline. So this time, for the semantic meaning of some things, the cosine similarity works better than the keyword search. Okay, let's jump to the slide now. Now, we understood that there are the question here that shall we use the semantic search or the keyword search? Now we know that the semantic search, one second. Okay, so semantic search is nothing but it's looks semantically similar content. But the keyword search, which uses the best match 25 algorithm, it exactly matches the query term. Now, whether this is good or this is good, because if we look at our example, we ask the query that what is the scientific name of cat. When I ask this question, what is the scientific name of cat, my keyword search is giving the better result as compared to my semantic search. And this is a very small example, right? Similarly, when I use the word feline, right, my keyword search absolutely give the value 0, but my semantic search gives the better result and the score is good here, right? Now in these two scenario, okay, there may be a multiple question because you don't know which question user is going to ask. Okay, and you cannot change this algorithm over the fly, so it's better to use the new type of search is called as a hybrid search, and that hybrid search is nothing but the combination of the keyword search and the semantic search, because if you use those two search altogether, the effects are great and you are not losing the context, or you are not using the exact match of what user is intent and the experience at the user level, or fetching the retrieval of specific document is good, and the ultimately your accuracy is good and your hallucination is reduced. Okay, let's jump to the how hybrid search works. now now this hybrid search works use one algorithm called as the reciprocal of rank fusion. It is not difficult, it's a very simple, but let's understand how it is works mathematically. Now RRF is nothing but the reciprocal rank fusion is a simple algorithm where we combining the different ranking of the different scoring. Okay, it is not something only works with the semantic or the keyword. If you want to combine the different scores from the different algorithm, you can combine here. Okay, so what is the idea behind the RRF is that it gives the higher weight to the items that are ranked higher in any individual rank list. Okay, I will explain in meaning what is the meaning of that. So this is the formula of to calculate the rank, or I can say score, and this is the mechanism behind the hybrid search. So it's a 1 upon k plus rd. Now his rd is nothing but the rank that you receive from each search. Okay, let's say we have keyword search and another is the semantic search. So the rank from the keyword search and the semantic search is fed here, which add with the value of k. Now what is the k? K is a something is a tunable parameter, and in the original paper of this reciprocal rank fusion they uses the k is equal to 60, and it works better. And this RD, R is nothing but the ranking which are received from the BM25 and the cosine similarity. Okay, now let me explain this, which is something with the help of example so that you can understand better how this works. Okay, now let's understand. Let's say I have one document, list 1 and the list 2. Okay, now you heard we have some corpus, right? So we will use the same corpus, and this is the document A which has a rank 1, document B I have got the rank 2, and the document C is a rank 3. Just for the time being, let's say that this ranking we will get from the keyword search. Okay, now this is a list 2 which has a document B, okay, got rank 1. Okay, so we will feed the same document here as well. Document C got rank 2 and the document A here got rank 3, and this we receive from the semantic search. Now if we look at the list 1 and list 2, which is from the semantic and keyword and the semantic respectively, document A is a rank 1 here and the document A is a rank 3. So ranking wise A is higher, but in the second is a rank 3. However, the ranking wise document B is come rank 2 and here it is come rank 1. So if you compare the document B gaining higher score as compared to rank A because it's a fusion. Now let's say we have the k parameter called as a 60. Now this 1 upon in the document A, if you look at this list 1, it is come 60 plus 1. In the second list we have it's 1 upon 60 plus 3. So it comes around the 0.0327. Similarly, if you go to the B, in the first rank is 2, so I add 60 plus 2. In the second list, I have the rank is 1, so 160 plus 1. If you calculate this, it comes upon 0.0333. Similarly, for the C, the rank is a 3, so 60 plus 3, and then here rank 2 is 60 plus 2 and is 0.328. So if for the ranking, when you calculate this, you can observe that the document B rank is greater than the document C, greater than the document A. So this is the mechanism they use. So this K is a 60, so generally we use the value of 60 to avoid the penalty kind of stuff, or to have these things normalized, because we don't want the because of some higher weightage, you know, gaining the higher value, and because of that for the normalization purpose this tunable parameter has been added. Okay, I hope you understand how this rank fusion works. Okay, now let's check the code how this hybrid search works. So here we use again numpy. So numpy we use because we first wanted to convert our scores into the number. Okay, so the higher the score we get first rank, lower the score second, third, fourth, likewise. So for this function is used to convert the score into the ranking. The second is the RRF. So RRF for the rank fusion. So we will combine the rank from the semantic and the keyword and calculate the RRF score. So this is the formula that I have explained in just now. Okay, let's execute and let's calculate the score. So we have the doc score from the keyword search, and if you execute we will get the score 4321. Okay, if you calculate the cosine score, okay, for the cosine things, first it's a tensor. If you look at this, let me just scroll back. This is something a tensor, so we need to first convert into the flatten, so that this two-dimensional array convert into the single dimensional array. Okay, and then after that we convert into the list. So that's why this is the additional steps we are using, and then we calculate the scores. And it comes 1 2 4 3. Okay, and this way, this is the function we have calculate, and we calculate the hybrid scores using the RRF, and this scores we have got. If you apply the scores to ranking, and this is the something ranking we got, which is a 4 1 2 3. And what was the question? What is the scientific name of the cat? Okay, now if you look at this, the scientific name of cat, the first getting the fourth score, definitely. Second got the first. Okay, and the third got the, okay, so it's a human are the most, and the last one is the scientific. So let's me check this, there is something wrong. Doc score, okay, I think I have taken, okay, the cosine score, it is used this one, so I have to execute this because the name is same there. So let me run this. And let me calculate this. Score will be changed here, and it scores, then scores, yeah, now 4 1. Okay, so actually, okay, no ways I have jumped to this, but I have segregate all these things just for the explanation purpose. So anyways, I have written all whatever the things I have explained, I have combined everything here. So under this function called as hybrid search, so let me run this. Okay, and let use the query, and we will get the value. Let me use front the same query. What is the scientific of cat? Okay, run this. Now see the scientific name of cat. Now the first is the cat, so definitely it got fourth rank. Second is the dog, it got third rank. Then the third is the uh, human are the most common and the widespread, and the scientific name of the felis is cat. So if you look at this, the last one is got the keyword first rank. Okay, and the semantic got uh, the, the first one is the second one. Okay, now if you combine this, we will got this rank 4 2 3 1. So the last one definitely get the higher rank. Okay, because if you look at the last score, the last is the 1 and the second is the third. Okay, so similarly it got the higher rank. Let's check the another example. Is human or animal? Okay, okay, so is human or the animal? So the cat got the third rank with the help of keyword. The dog got the fourth. The third, as per the keyword match, it got the second rank definitely. And I'm talking about the keyword ranking. Okay, and the last one is the first one. Okay, because it has something called as a scientific name. Okay, scientific name. If you look at the semantic ranking, in the semantic ranking we got the similarly the first one is the third, then the second one is the dog. Okay, and the first one third one is the first rank. So semantically this one is the correct? So definitely, and the ranking wise is again it got changed. So the 3 4 2 1. Okay, so I hope you understood this thing very well, and you understood how this hybrid search works better as compared to uh, no as compared to this one, the semantic and the keyword. Okay, so let's jump to the another part of this. We have done with the code. Yeah, so this way we completed the lecture, and I want to thanks to the Dr. Leon. uh, he, with the help of his article, I'm able to explain this. If you don't understand any part of this thing, please feel free to comment in the comment section of this video, so that uh, I'll able to answer it. I'll share the presentation plus notebook the comment section or in the description of this YouTube video, so that you will refer and you can play with this, you can customize it, so that you will get the better understanding of this. Okay, thank you so much and keep watching.